I'll be explaining a relatively simple algorithm called the BFS. It's a counterpart to the DFS. DFS, you would search a graph like this. A BFS, you would search like this. So as the name kindly suggests, breadth first search. So that this would be the traversal order. Let's remove all of that. So conceptually, that's super easy. Now, how do we implement this? So this is the function you're going to be using for BFS. I'm assuming you guys know what the visited array and the adjacent array of vectors is, or you can use a two-year array for that. But anyways, I want to make this video as concise as possible. So let's get started. So we would conduct the BFS, and of course we would start the BFS from our root node, which is 1. This function runs recursively, so we can just run the BFS from the root node. And then we would declare a queue. You guys will see why in just a second. So let me just draw a huge queue here. And then our current node is 1. We would push our current node inside. So that'll be 1. And then now, while there are elements within the queue, we would repeat these steps. So current is queued up front, so our current node is 1. Now, we visited it, so we would set visited as 1. You can use a boolean array for visited, doesn't really matter. So 1 is visited. We're not visiting that again. So now that we set 1 as the current node, we would just pop it out of there. So bye-bye. And then we would traverse all of the adjacent nodes to 1. So that'll be 4 and 2. So next is going to be 4, and 4 is not visited, so we would just push 4 into the queue. And visited, mark it as visited. Now we're still in the for loop. Now we're looking at 2, and next is 2. 2 is not visited either, so we would just push 2 inside and set it as and mark it as visited. Okay, nice. Done with this for loop, we inserted all of the adjacent nodes. So now current would be q.front. What's in front is 4, right? So we would pop this just like we did with 1, and then now we traverse again all of the elements that are adjacent to 4. So we would start with 5 and then we'd go. So next is 5. 5 is not visited. We would push 5 into the queue. So push 5 in here, and then we would mark it as visited. So you realize how we're traversing all of these one by one. Okay, where was I at? And then now next is 3, because we're still in the for loop, and 3 is 3 is not visited, so we would just shove it in there and mark 3 as visited. Okay, and then now cur is 2. So 2 is this, and then now we would just okay, just remove 2. But then 2 doesn't have any adjacent nodes, so we're just going to exit this for loop immediately. Current would be 5, because q.front, but again 5 has nothing adjacent to it, that's not visited. So same thing for 5, and now we land at 3. Same thing for 3, there's nothing adjacent, so the for loop wouldn't run. So we would also come to 3 and we would pop. And that's the BFS, and you realized we first visited this one, and then we visited this one, we visited this one, we visited this one, visited this one. Again, this should be really straightforward if you're familiar with DFS and you're familiar with recursion. So now I need to show you that my implementation actually works. So here we have our visited array and our adjacent array of vectors, and we have our main function. So number of vertices, number of edges, and then we would input all of the nodes that are connected via a path, and we would just BFS our root node like I mentioned. So this is the key logic, but these are just the inputs we need to actually conduct this BFS. So let's give it a try. So let's see how many. So we have 5 vertices and we have 4 edges. So we just 5 and 4. And then now we would just input all of our nodes. So 1 is adjacent to 4, 1 is also adjacent to 2, and then 4 is adjacent to 5, and then 4 is adjacent to 3, which should give us a result. So here, 1, 4, 2, 5, 3. Nice. Let me just draw a smiley face. Yeah. Yeah. Hopefully that was helpful.